Okay, boys and girls, this is Mr. Knoll bringing at you problem solving lesson 24. First two pages are a review over square roots. If we look first off, definition of a square root down here in the bottom right hand corner. Square root is a factor of a number that when multiplied by itself results in the number. So for example, it says 9 is the square root of 81 because 9 times 9 is 81. If you think back to Unit 1 that we did in class, Unit 1 was over, parts of it were over square roots, and we just need to remember that square roots are a factor of a number that when multiplied by itself results in that number. Taking a look at this example, it talks about Leroy's backyard. It gives us the expression A for the width of the yard and 3 times A for the length of the yard. Goes on to show the perimeter. Perimeter is distance around Leroy's backyard, is represented by this expression. Remember, we can combine like terms to get a final expression of 8 times A if we were to add the 4 sides together. Second thing it shows us is that area of a rectangle is length times width. So the area would be A times 3A, or again we could simplify it to 3 times A to the second power. Suppose you know the area of a yard is 7,500 square feet. How can you find the value of A? If we take a look, the area is equal to 3 times A to the second power. So we can write the equation. We could say the area is equal to 3A to the second power. Since we know the area is equal to 3A to the second power, we can write an equation. The equation is 3A to the second power, again, area of the square, and they tell us in the problem the area is equal to 7,500. With that being said, number 2 is basically solve the equation we wrote for number 1, okay, and that's using the inverse operations and steps to solve equations that we have learned. Using the inverse, first off, to isolate the variable, I'm going to use the inverse of multiplying by 3, so I'm going to divide both sides by 3. That would leave us with A to the second power is equal to 2,500. Solving a squared equation, the inverse of squaring an equation is finding the square root. So next step in this case would be find the square root of both sides, which would then leave us with A is equal to 50. It goes on to say what is the perimeter of the backyard. Remember, up in the directions they told us the expression for perimeter is 8 times A. So if the expression is 8 times A and A is equal to 50, we just have to evaluate that expression by taking 8 times 50. Because A is equal to 50, final value is 400. We're talking about perimeter, so to correctly label, perimeter is just in that unit. So it's 400 feet around Leroy's backyard. Okay, moving on to page number 2. The area of a floor of a square room is 144 square feet. What is the perimeter of the room? Include a diagram in your solution. So let's draw a square. I'm drawing a square because it says we have a square room. The area is equal to 144. With that being said, to find area of a square, you take the length times the width. Definition of a square, length and width are the same value. So this meets the definition of a square root because we need to multiply the same number times itself to get an area of 144. Solving this equation, the inverse of squaring a number is find the square root. The square root of x squared is x. The square root of 144 is a perfect square. Comes out to equal 12. This is not our final answer because the question is asking for the perimeter of the room. Perimeter could be written as x plus x plus x plus x, because we're adding up the four sides of that square. Or we could write an expression, since those are all like terms, 4x. If x is 12, 4 times 12 is equal to 48. So the perimeter of that room, 48 feet. Number 5, which two numbers in the box are perfect squares? Explain how you know they're perfect squares. Well, perfect square is when you find the square root of a number and it comes out to be a perfect whole number. So basically what we would want to do, find the square root of each one of these values. If you find the square root of each one of these values, two of them, obviously, because the question says which two numbers, two of them will come out to be perfect squares. And the ones that are perfect squares are 196 and 600. That's a 5, by the way. 625. Okay, explanation would be that you multiply a whole number times itself to get these values. Okay. When you found the square root of 196, it comes out to be 14. 14 times 14, or a whole number times itself, equals 196. Same thing with 625. What is the side length of a square whose area is 1/64 of a square mile? This question is very similar to number 4. We have a square. Area of this square is 1/64. To find area, we multiply the length times the width. So once again, we could write the equation x to the second power is equal to 1/64. Even though it's a fraction, we do the same thing. It's a squared equation. The inverse of squaring an equation is finding the square root. And if you find the square root of x squared, value comes out to be x. The square root of 1/64 comes out to be 1/8. So the side length of that square is 1/8 of a mile. Obviously, explaining your answer, I used my work to explain my answer to show what our reasoning was. Finally, number 7, Natasha says that if the area of a square is A, then the length of the side of a square is the square root of A. Do you agree? Yes, we do agree. Of course we agree. Especially if Mr. Fricky says so. If we look at all of these values that we've done so far, basically if we're given the area, we find the square root of the area. And in this case, if the area is A, then the length of the side of the square would be the square root of A. So with our explanation, we just need to say basically something to the effect of if the square root of A is the length of a side. Uh-oh, what happened here? The length of a side, sorry about that, little technical difficulties. Of a square then the square root of A, then the square root of A squared to the is the area of that square. Okay, moving on to page number 3. Page number 3 starts off with solving problems using right triangles, and this is where we get into the Pythagorean theorem. Okay, taking a look at this example, basically it's saying Mr. Nichols, he drove 6 miles south, he then drove 5 miles east, he then drove 3 miles south, that's a 3 everybody, and then he finally drove 7 miles east to get to the campsite. In all, how far did he drive? Well, how far did he drive? It would be a total distance of 6 plus 5 plus 3 plus 7, which equals 21 total miles. Question is going on to say, if he could have drawn or drove straight from the entrance right to the campsite, what would that distance be? Now, if you notice, they drew in a right triangle. Since we're dealing with right triangles and we want to find the length of a side, we can use the Pythagorean theorem, which is the square off of A plus the square off of B is equal to the square off of C. And that helps us find unknown distances in right triangles and right triangles only. Number 1, find the distance if Mr. Nichols had been able to drive straight from the entrance to his campsite. We just need to solve this equation, the Pythagorean theorem. Excuse me. Okay, so evaluating this expression, 9 squared plus 12 squared. Well, 9 squared is 81. 12 squared is 144. Those two values together equal the square off of the side we call the hypotenuse. Adding those values together, we get 225. Oops. Sorry. That's supposed to be a C. And then once again, to find the value of C, if C squared is equal to 225, the inverse of squaring an equation is finding the square root. So if I find the square root of C squared, I get C. The square root of 225 is 15. So if he had been able to drive straight from the entrance to the campsite, he would have to drive 15 miles. 2, how much shorter would Mr. Nichols' drive have been if he had been able to drive straight from the entrance to his campsite? Remember in the example, Mr. Nichols had to drive 21 miles. If he could have driven straight, he would have only had to drive 15. We need to find the difference. 21 minus 15 is equal to 6. He would have driven 6 miles shorter. Okay, taking a look at number 3, you tie a spherical balloon, which just means a circular balloon that is 2 feet in diameter, to a stake in the ground. The string is 15 feet long, the wind blows, and you observe that the top of the balloon is now 8 feet over from the stake, as shown in the diagram. What is the height of B? Well, if we look, we have a right triangle. Once again, if we see the right triangle and we want to find an unknown length of a side, we can use the Pythagorean theorem. So we're going to start off using a squared plus b squared equals c squared. Now, if you remember in our favorite Colin Dodds video, A and B are always the two shorter sides, or what are called legs, of a triangle. C is the side opposite the right angle, and it is called the hypotenuse. So if we evaluate this equation and substitute values in, I know A is 8 because it's one of the shorter sides. B is the other shorter side, and we do not know the value of B. We know C is the side opposite the right angle, which would have a total length of the 15 feet of the string plus the 2 feet of the balloon. So total feet would be 17 square feet. I'm sorry, 17 feet. Okay, now using what we know about solving equations, we are just going to go through. First off, evaluate expressions. Second off, solve the equation. So first thing to do to solve this, let's evaluate 8 squared and evaluate 17 squared, which is 289. Going through solving an equation, I look to isolate the variable. I got to use the inverse of 64 or adding 64. So I'm going to subtract 64 from both sides. That would leave me with b squared equal to 225. And we're left with a squared equation. And folks, if you haven't heard me say it yet, I'm going to say it again. Hey, the inverse of squaring an equation is find the square root. So to find the value of b, we take the square root of 225. b is equal to, b is equal to 15. So the height of the balloon would be 15 feet. Number 4, in problem 5, the wind blows harder and the top of the balloon is now 15 feet over from the stake. What is the height of the balloon now? Draw a diagram to help you solve this problem. Well, once again, we know the total length of the balloon string and the balloon is 17 feet. Here's our stake in the ground, 17 feet. The distance from the stake now, it says, is 15 feet. So the balloon is over 15 feet. What is the height? I will label that B. There is our diagram. We have our right triangle, so therefore we can use the Pythagorean theorem. And we go through and solve. I'm going to try and solve it here. So we would have 15 squared plus b squared equal to 17 squared. Solving that equation, evaluate. 15 squared is 225, 17 squared, 289. Solving this equation, I'm running out of room. What you would do is subtract 225 from both sides, which would leave you with b squared on the left and 64 on the right. We have a squared equation, so to find the value, the inverse of squaring a number is finding the square root. So the value of b is the square root of 64, which is equal to 8. So that balloon is now 8 feet above the ground. Number 5, the perimeter of an equilateral triangle. Critical part here is equilateral triangle is 48 centimeters. Use estimation and find the height of the triangle to the nearest whole number. Include a sketch in your answer. So I'm going to start by drawing, to the best of my ability, an equilateral triangle. Beautiful. Okay, equilateral means all three sides are the same length. Well, if the total perimeter is 48, then the length of each side would be 48 divided by 3, which is 16. So each one of these sides on this equilateral triangle is 16 centimeters. Question is asking us to find the height of this equilateral triangle, which would be that red line right there. We just created a right triangle. With this right triangle, we can use the Pythagorean theorem to figure out the height of that triangle. Now, based on this information, I know this part, and I'm going to draw it in blue, of the base of that triangle is 8 centimeters. I know it's 8 centimeters because it's an equilateral triangle, and that part of the triangle would be half of 16, and half of 16 is 8. So we have a right triangle. We can then use the Pythagorean theorem. We want to find, maybe, the height of that triangle. So we know one of the legs is 8. We know the height. I'm just going to use h for the height. We want to find the height. We know it's a leg because it's a side connected to the right angle. We know the hypotenuse of that triangle is 16. Going through, evaluating, and then solving. 8 squared is 64. 16 squared is 256. Next up, to solve for h, we have to isolate the variable. Take away 64 from both sides. h squared would be left with 192. The inverse of squaring an equation is finding the square root. So we would want to take the square root of 192. And the square root of 192 comes out to be a value between 13 and 14. And what you would notice, your next perfect square is 196, which is equal to 14. And 192 is pretty close to 196. So because we're using estimation, it said, to find the height, I am going to estimate that triangle to be approximately, okay, that's a little wavy equal sign there. It's going to be approximately 14 centimeters. Okay, page 247 shows us in the diagram a rectangular prism, and we see some sides that are labeled. Directions are going to say use the Pythagorean theorem to solve for C, then use C to solve for D. First off, number 1 says, how do you know that the triangle with side lengths 6, 8, and C? And I'm going to trace that triangle to the best of my ability. 6, 8, and C. I know when we look at it, it does not look like a right triangle based on the diagram. But we have to use the definition of a rectangular prism to answer number 1. It says, how do you know the triangles with length 6, 8, and C is a right triangle? We know it's a right triangle by definition of a rectangular prism. So I'm going to start off by writing that. Sorry about my writing. By definition of a rectangular prism. A rectangular prism is a prism made up of rectangles. And a rectangle by definition, a rectangle is a four-sided shape with 4 90-degree angles. So we're going to say a rectangle only has 90-degree angles. And if it only has 90-degree angles, that means the triangle that we drew up there in red has a 90-degree angle, which makes it a right triangle, which means we can use the Pythagorean theorem. Number 2, how do you know that the triangle with side lengths C, 24, and D? And I'm going to trace that in blue. So C is this side. 24 would be the height of that rectangular prism. And then D is that dotted line that goes from point A, or vertex A, to vertex B. How do you know that that triangle is a right triangle? Once again, definition of a rectangular prism. We're going to start with that. By definition of a rectangular prism. And again, the definition of a rectangular prism, we're going to say all faces. And when we talk about a face of a rectangular prism, we're just talking about the sides. All faces meet at a 90-degree angle. And if all faces meet at a 90-degree angle, once again, we've created a triangle that has a 90-degree angle, which is a right triangle, which means we can use the Pythagorean theorem. So for starting off on number 3, use the Pythagorean theorem to write equations to find the values of C and D, find the value of C, and then the value of D. So let's start with that red triangle. C is the hypotenuse, so we can write an equation for C. If I look at the red triangle, one of the legs is 6, the other leg is 8. We need to find the length of the hypotenuse. Evaluating and solving, 36 plus 64 equal to the square off of C. Those added together is equal to 100. And to solve for C, we have to find the inverse of the square of c, which means we find the square root, which leaves me c to equal 10. Now find the value of d. Well, if we look at d, and it's hard for me to write it up there, but we now know the length of that side labeled c is 10. We know the side length of that blue triangle is 24 and 10. So we can write an equation to say 10 squared plus 24 squared is equal to d squared. And we're using our value of c, which is 10, to help us solve this equation. Evaluating, 10 squared is 100, 24 squared, if you type it in, 576 equals d squared. Adding those together, 676 is equal to the square off of d. To solve that equation, we take the square root of both values, d equal to 26. Okay, looking at number 4, it says between what two whole numbers is the length of the diagonal from m to n? Now, before we find the length from m to n, we have to find the hypotenuse of the base of that rectangular prism. So, what we need to do is find the hypotenuse of a triangle who has two legs that are 8 and 12, which would mean we can use the Pythagorean theorem. 8 squared plus 12 squared is equal to c squared. So we're finding the base of the hypotenuse, or the hypotenuse of the base, I should say. So evaluating this expression, or this equation, we would have 64 plus 144 equal to the square off of c. Adding those the values together, we get 208 is equal to c squared. Once again, to solve a squared equation, we find the square root of both sides. The value of c in this case, because it comes out to be a non-perfect value, or a value that's not a whole number, I am going to leave the value of c to equal 200, or the square root of 208. So, try and follow with me here. We now need to find the length of the diagonal, which is that blue line from m to n. We found the bottom, this leg that I'm tracing right here, and I'll even make it in black. Okay, the base of this, what we just found in our answer, is the square root of 208. We know the height of this triangle, okay, is 6 centimeters based on the information that's provided in the diagram. So we have one leg that's the square root of 208. We have the other leg that is 6. We have a right triangle, and now we need to use that information to find that blue line, which is the diagonal that connects point M to point N. Using the Pythagorean theorem, 6 squared plus, and we have the square root of 208 squared. Those are the two legs of the triangle, equal to the diagonal, and I'm going to again call that c squared. That's the hypotenuse, the blue line there. Evaluating this expression, 36 square root of 208 squared is 208. Adding those values together, we get a total of 244 equal to c squared. To find the value of c, we take the square root of that equation, and the square root of 244 comes out to be between 15 and 16. The question is asking between what two whole numbers, so our final answer, we would want to say between (15) and 16. Okay, and I should also label those 15 centimeters and 16 centimeters. Hey, number 5, same thing. Tyler wants to ship a fishing pole that is 7 feet long. He will use a box that has a rectangular prism with a base that is 4 feet by 3 feet. What is the shortest whole number height that will hold the fishing pole? So when we look and start evaluating this expression, or I'm sorry, this situation, we need to first find the hypotenuse of the base, okay, which is a right triangle that has legs of 4 and 3. So, starting out using the Pythagorean theorem, we would have 4 squared plus 3 squared equal to c squared. Evaluate the expressions. 16 plus 9 is 25. So the hypotenuse of the base is the square root of 25, which is 5. So the hypotenuse of that base is 5 feet. Now, using information to find these next values. Remember, Tyler wants to ship a fishing pole that is 7 feet long. So, the distance from one corner to the other corner has to be at least 7 feet. Well, what we've just created now is a right triangle. We need to figure out the height of that box. We know in our right triangle what we just found, the hypotenuse of the base. This side here is 5 feet. We know the hypotenuse has to be at least 7 feet. So we can write the equation 5 squared plus d squared equal to 7 squared. Solving that equation, evaluate the expressions first. 25, 7 squared is 49. Isolate the variable, subtract 25 from both sides. D squared is going to be equal to 24. To find the value of D, we need to take the square root of both sides, which would mean D is the square root of 24. Questions asking, what is the shortest whole number height that will hold the fishing pole? Well, the fishing pole would fit in the square root of 24. The closest perfect square to the square root of 24 is the square root of 25, which is 5. So what is the shortest whole number height? The shortest whole number height would be 5 feet, because 5 feet is the closest perfect square to the square root of 24. Okay, you are going to skip number 6. That's a Mr. Knoll bonus for you. You're going to skip to number 6 and move on to the next page. Okay, you're going to complete page 249 and 250 for homework tonight, or finish it up in class, whichever you're able to do. I'll quickly, as you're going through this, give you some hints as to how to solve some of these. If we look at number 1, Elsa's flying a kite. She let out a 25 meters of string. The kite is directly above a spot that is 7 meters away. How high above the ground is the kite? Well, if we think of Elsa's right here. She's flying a kite. The kite has a string of 25 meters. It says the kite is directly above a spot that is 7 meters away. So this spot, 7 meters away, you are trying to find the height. We have a right triangle. Go for it. Number 2, okay, we have a rectangular prism. What is the length of the diagonal from point R to point S? Very similar to the two questions we did previously. The first thing you want to do, or you will need to do, is find the hypotenuse of the base of that figure. I know it's hard to see, my drawing isn't perfect, but there's a right triangle on the base of that figure. You need to find the hypotenuse. Once you find the hypotenuse, you need to use that value to find the the hypotenuse of that rectangular prism. Remember, this side is going to be 4 inches. Okay, number 3, your hint to you obviously is to find the hypotenuse of that right triangle that is given. You want to then use the hypotenuse to find the perimeter of that square. To do that, if you know one side, the perimeter of a square is the one side multiplied by 4. With number 4, you just need to read through. Remember, the Pythagorean theorem states that, a squared plus b squared equals c squared. And you just need to think through what is being described there and see if it represents what is true about the Pythagorean theorem. Number 5, we got to know what the definition of an isosceles right triangle is. An isosceles triangle is a triangle whose has two sides that are the same. So, to figure this one out, your diagram, an isosceles right triangle, which means this value and this value are the same values, or A and B are the same numbers. It says it has a hypotenuse of 12. Use what you know to figure out the length of that length, I should say the base and height of that isosceles triangle. Number 6, they're giving us dimensions for a rectangular prism. Just like my friend says over here, you can draw a diagram to help you visualize this problem. Folks, this problem right here is similar to the rectangular prism problems that we have done. Use the information. Use your knowledge about the Pythagorean theorem to figure out the height of that prism. With that being said, folks, hopefully this helped you out, guide you through problem solving lesson 24. I'm looking forward to being back at home and working on this stuff along with you. So I will see you guys soon. Peace out. Adios.